So last time we were talking about this three-tier architecture diagram. So any questions so far on this, if you have? Yes, guys, related to this particular diagram, do you have any question? Yes, guys, any questions so far on the particular things we were discussing last day? Guys, any question? Or shall we move ahead? Okay, so I have a question if you don't have. So how does three-tier architecture work? Who will answer the question? How does three-tier architecture work? Guys, who will answer?
As web tier, application tier, and database tier.
So only these three statements, three line. Only these three line statement will work, guys. I took more than 50 minutes to explain that. Guys, any other one would like to explain?
You have the presentation tier. This is a user interface layer that's responsible for displaying data and facilitates user interaction. You have the application tier. This layer contains business logic and rules for processing data. It communicates with the presentation tier to pass data and receive user requests, and communicate with the database tier to retrieve and store data. You have the database tier. This store the data and provide interface for application tier to access the and manipulate the data.
You're right, very true. Okay, so let me tell you how does it look like. The very first thing here is we have a particular server which is known as DNS. DNS server is basically used to host your website, right? Then after we have another, like this is obviously public DNS we are talking about. If we talk about AWS, so definitely on the top of AWS, we have multiple type of record sets, which we discussed, right? Okay. Now, when we are talking about DNS will forward the request to load balancer. This is going to be application load balancer, application elastic load balancer, right? Second thing, it is going to be internet facing. This load balancer will be internet facing. This will accept traffic on port number 80 and 443. If you want, I can define the port numbers as well. So this will accept traffic on port number 80 and 443 both. because it is supposed to accept traffic on port number, like on protocol, which is known as HTTP and HTTPS as well. That is 443, not 433. Okay, 443, right? Now, these are going to be web servers. So let us say we have multiple web servers here. So we have this kind of instances here. These three instances we have, and these instances are being used in order to serve your web application, right? Now, why did I create multiple today? So guys, keep this thing in mind. There are two types of architecture. First of all, it is known as monolithic. Second one is microservice. So is there anyone who has any idea about like what is difference between monolithic and microservices?
Monolithic is when you have bunch of application in one container. Let me just give an example, like one container. Well, microservice is like it's separated into different where you have the carts, you have the checkout, you have the interface. You have maybe microservice, you can have up to like 100 applications sometimes. So I don't know if that's answer the question.
Yes, almost near to right you are. So when we talk about monolithic, so let us say we have only one application and that contains whole business logic. Now what happens here is, let us say if that application goes down, so entire business either will be up or will be down. So in order to ensure that our application is not impacted, if one application is going down, then rest of application should be working as expected. That is first requirement here. Second thing, so what is microservice architecture here? Microservice means, let us say, when we talk about this particular, let us say this is app.diagrams.net. There is a particular sub URL of it, which says app. Maybe there could be another one. Let us say web.diagrams.net, then after api.diagrams.net, then after login.api.net, then after it could be graphs.diagrams.net. It could be, let us say, checkout.diagrams.net. So what happens? Let us say if this is the particular picture. So what would happen? Let us say I'm going to define this. Next one is going to be api.diagrams.net. Let us say like this. Then after, if I want to create another one, let us say this is going to be login. Login.diagrams.net, right? These three URLs are there. Now, what do I want? I want to create this particular step in such a manner that if app.diagrams.net is coming, if request is coming for app.diagrams.net, that request should be forwarded to these three set of servers, right? So we can define that app.diagrams.net here within our first box. This is for app.diagrams.net. Okay, let us say if we have another URL which is known as api.diagrams.net, and last one is known as for login.diagrams.net. So if we have this kind of architecture, like where we have set up and we have created this kind of architecture, like we are creating and we are using these servers in such a manner that these servers are being used for let us say login service, for app API service, for login service. So this kind of infrastructure is known as microservice architecture. And why is that so? Let me tell you that as well. So every single server, whatever you have, this is for API, let us say this is for app, and this is for login. Right, guys? So now what is going to happen next? So this is known as like DMZ zone, or you can call that front layer. These applications are going to be treated in DMZ zone. Moreover, guys, we talked about auto scaling. Every single target group. So obviously these three applications will be part of any target group. So we will have auto scaling group configured in order to ensure that yes, these applications are up and running. We can set some set of rules here, and this set of rules will be configured in order to maintain the state of these applications. So we are going to keep, guys, there is only one difference which we are going to discuss today. Last time we discussed like only about like monolithic application, but this time we are talking about microservice architecture, because right now, guys, whenever you go, 99% organizations are working only with microservice architecture. That's what I'm trying to explain you. Like, how does it look like? Okay, so very next thing here is going to be, let us say we will have another box here, right? Now, we will have these kind of,
I have a question quick.
yeah, please go ahead.
Yeah, so does it mean that each instance template is separate based on the microservice? So if we
Yes.
have like 4 different APIs or microservices, we're gonna have 4 different instance templates as well.
Yes, you are right. And you are absolutely right. You can say like when we are talking about, these are known as like services for web. This is for DMZ. Now, when we talk about like app, API, and login, these three are the functionality which are based on API, which are based on like URL path, right? So if these three instances are working over here, let us these can be containers, these can be virtual machines, right? So there could be multiple instances running for same API, for same URL, but these are going to serve the same content. Like the code which is going to run on these servers is going to remain same. Now, once again, we will have a particular load balancer. Now, this load balancer will be known as internal load balancer.
Network load balancer, right?
Right. Internal network load balancer, it is going to be. Now, what will it be doing? So it will start accepting traffic from this particular machine based on the particular port numbers, because obviously when we are talking about like different ports will be utilized here. So all these three applications may use this single internal load balancer. And let us say this is for app, this is for application server, these are web. App.web server, we can call it. API.web server, we can call it, like, because these are web servers, right? We should not have a confusion. So that's why I'm writing here web. So these are like login.web, API.web. These are web servers for this particular application, which is known as app, maybe API, and maybe login. So these, whatever services are these, so we are talking about that these are the services which are running with web servers, right? Okay. So now when we are talking about this, when we are talking about this particular stuff, so these are the particular servers which we have right now. And these all servers will forward request to internal network load balancer, because this particular load balancer is not going to accept any request from internet directly. This will be accepting request from these services. Now, when we want, like this is going to be app server for sure. This is also going to be app server, and this will also be going to be used for app server. But what kind of app it is? Let us say, first of all, let us say it is like app.app. Like this is going to be application server for app URL. This is going to be API.app. This is going to be API service for app. Like this is going to be API servers, which where the application will be running. Then after it is going to be login.app. Right? These are application instances, or these are not, you can call that like microservices will be running here. These instances will be used for front end, these will be used for application layer. But as you see, there are different kind of applications like app.diagrams.net, app.api.diagrams.net, login.diagrams.net. That is a main URL with us, right? Okay, so there will be a particular rule. Let us say if these particular servers are requesting for port number, let us say we are going to define here that our app instances are running on port number 8081. So if request is coming for this particular port number, request will be redirected here. Now let us say our API service is running on port number 8082. So if these web servers, this load balancer accepts any request for port number 8082, that will forward request here. Now let us say our login service is running on port number 8088. So that request will be forwarded here onto this particular URL. These kind of rules are set here onto this network load balancer. And going forward, let us say that like a number of instances, whatever you want to have here. For example, you want to have 1, 2, or maybe 5 instances. So you can definitely have replica of this instance within your target group. And once again, this target group also be managed by some auto scaling group. Right, guys? This particular app dot port number 8081, if request is coming on port number 8081, so request will be forwarded here. If it is coming from API.app, then it will be forwarded here. And you can have n number of instances within this particular target group, which you can place like this. The same way, you will see the particular traffic being routed for other kind of application, and which is going to be for your login.app, and port number is going to be this one. Are we clear with that, guys? Guys, are we clear with that?
Yes.
Yes, sir. Yes, sir.
Okay, great. Sounds good. Now, finally, we will have DB. These are going to be prod. And guys, now we are talking about microservice architecture, right? So this is going to be DB. So we will have a particular master DB. Then after we will have slave of it. Slave or slaves. Based on the requirement, we may have multiple slaves available here. Once again, there will be a particular load balancer. And behind this load balancer, like there will be two. So guys, let me tell you one more thing. Sometimes there is a requirement that we want to have such kind of configurations available, which shall be able to determine whether the request is coming for read or for write. So last time I told you that we can have here like proxy SQL. There is a particular software known as proxy SQL. So we can use that particular. So request will go here, or let us say in other words, what you can do here is there will be two load balancer utilized. First of all, internal load balancer will be used, that whenever request will come from these instances, request will be routed to this load balancer. Okay. Request will be forwarded to this load balancer. Now that load balancer will further forward request to these proxy SQL servers. And this proxy server will forward request once again to load balance, will forward request to these particular database servers. Right, guys? Because this load balancer will be used for high availability of these proxy SQL servers. Let us say if this goes down, load balancer will be able to handle, and entire request will be served by this. And if this goes down, then request will be served by this particular. This is also going to be internal load balancer, guys. Are we clear with that?
Yes.
Now,
I have another question.
yeah, please go ahead.
Yeah, so for the internal network load balancer, basically for the application layer, why do we need to have ports in there, considering the fact that we have specific instance templates for the app, as well as for the API, as well as for the login? Why do we need further port mapping for the network load balancer or for the application tier?
Okay, got it. So let us say if we have only one port, let us say we have only one port, because see, whenever we run any application, one port is open for that, right? So if we have only port number 8081 opened for every application, let us say app.app is working on port number 8081, API.app is working on port number 8081, same way like login.app is also working on the same. Then how will this load balancer be able to identify like where to send the request related to API, related to login, related to app? Because network load balancer does not have understanding of URLs when isolating the network. It can only work based on the port-based routing, but it cannot do routing based on the host name.
Oh, okay. So we're basically
that is
saying
why-
that.
That is why the isolation is done here based on the port numbers rather than URL. Like app.diagrams.net, API.diagrams.net, login.diagrams.net.
Okay. So basically, we're telling the internal network load balancer any request coming from login.web app layer, web layer or DMZ, just go to the login.app on port 8088.
You're right.
Essentially.
You're
Okay.
right.
Okay.
Because we will have to put some kind of logic here based on which we shall be able to distribute traffic across multiple target group. Like this is a target group for application, this is for API, this is for login.
Mhm.
So that is why rather than creating any other logic here, what we have done, like we have ensured that like we are going to run API.app on 8082. We are going to run like login.app on 8088. These are going to be like different ports, and network load balancer will understand that if request is going to come for port number 8088, then I have to forward this traffic here.
Okay. And we don't need to do that for the DMZ because we can
Because,
specify
yes.
the URL.
Yes, because this is
Mhm.
application load balancer, and this understands the particular URL or the particular routing based on host, based on path. So multiple kind of routing we can definitely do with the help of application load balancer. That is why we have not done over here like port-based isolation. We accepted traffic from like, let us say on port number 80 or 443, and we forwarded it onto different target groups or different port numbers. That is not a challenge for us. But over here, because network load balancer is not smart enough to understand the logic which we are going to put in order to do isolation of traffic based on URL, but it understands only the isolation based on the port numbers. Now, guys, this
Yeah, that makes sense.
this is for your like traffic flow. How does your traffic work? Now, let us say if someone is going to ask you during interview that how do you monitor your infrastructure? Where do you keep your particular servers? Where will you keep your servers in order to enable monitoring? Moreover, let us say this is going to be for monitoring, because whatever kind of servers you are running, right? Whether it is DMZ, prod, or your what you can call that, like DB servers are running. So you will have to place monitoring on the top of it. Right? So where to keep, like it is known as DMZ zone, it is known as prod zone, or it is known as DB zone. So what do we call this? This is known as management zone. This is known as management zone. So like what does that mean, management zone? So guys, all of your servers which do not have any kind of customer data available on it, but yes, these particular tools are used in order to ensure that your services are running fine, and you are going to do monitoring, you are going to set some kind of automation tool. You want to have Ansible, maybe Jenkins, maybe Bitbucket, maybe GitHub. So if these kind of tools you are going to have, for example, you want to host your organization internal tool known as Jira, right? Moreover, you want to do kind of log management. So Elasticsearch, Logstash, Kibana. So all the applications where customers are not hitting directly, but yes, you want to do some kind of better management for better visibility. You want to create internal dashboards from the logs which are received from different application server, web server, maybe databases. So you can create those kind of servers within management zone. What kind of servers are going to be kept here? First of all, it is known as, let us say, Jenkins. Why Jenkins is kept here in management zone, guys? Keep this thing in mind. Does Jenkins have any kind of request coming directly from any customer?
No.
Yes, guys. Jenkins server is used for doing CI/CD, continuous integration, continuous deployment and delivery, right? So does Jenkins server accept any request directly from customer?
No.
No. So that will be kept inside your management zone. Second thing, let us talk about Git, or you can call that Bitbucket or GitHub. Or GitLab. Like end of the day, whatever name you call it, it is going to remain Git only. So you want to host your internal Git repository. So you will keep, where will you keep it? Inside this. Then after, let us say you want to ensure, for example, you want to update any like individual file on these servers, like onto these or onto these. You want to change, let us say suddenly your internal DNS stopped working and you guys have defined only internal DNS server IP address onto web servers, onto app, DB, proxy, SQL, and whatever the servers are, each and every DNS server, each and every server is consuming internal DNS server IP address. So suddenly that has stopped working, that is not functioning, and because of which multiple applications which were supposed to access any other service based on the domain name, that is not working. So what will you do? You will have to write a playbook in order to update entire infrastructure within a while. So what will you do? You will need to place Ansible. So where will Ansible be placed? In management zone, right? Now, let us say you are talking about that you need to monitor these services, like what is response time of this, like how logs are working, how logs are behaving, whether you have any packet loss over network, whether your network is overutilized, underutilized, your server is overutilized or underutilized, that kind of, right? So after Ansible, what we are going to do here, we are going to place monitoring tool, let us say Prometheus, or maybe let us say Nagios, any kind of monitoring tool. I'm not being like tool specific, but what I mean to say is like monitoring tool has to be there only. Now, where will you host the particular services? Where will you host the services where you will start tracking of your task? Let us say it is going to be Jira, Confluence, or let us say any other services which are common, but you do not allow customer to access these services directly. Right, guys? Let us say you are going to talk about centralized log management like ELK, Elasticsearch, Logstation, Kibana. Where will you host these kind of services, guys? Into management zone. Because let us say if ELK goes down, if Elasticsearch, Logstation, Kibana goes down, so any customer will not be impacted by that. If Jenkins is not working, will any customer have any impact?
No, sir.
If Git stops working, will any customer have any impact on this? Same thing goes with Ansible, Prometheus, Jira, Confluence, ELK. It means all the tools which will affect the work of internal engineers or internal employee of the organization, but these are never going to make any kind of impact on the life of end user. So if that is the case, then what to do, guys? We need to host these kind of services into one separate zone, which is known as management zone. So based on the requirement, you may or may not have public IP address associated with these services, because these services are supposed to be accessible from within your on-prem data center, or maybe from the particular location where do you work, like from office IP address. So ideally management zone is not supposed to have any kind of public IP address, but yes, based on the requirement, you may allow, but not recommended. Are we clear with that? Like where do we keep Jenkins, Git, Ansible, Prometheus, Jira, Confluence, ELK kind of softwares? Otherwise, just for example, let me tell you, we could have placed Jenkins within this particular layer, Git within this particular layer, Ansible within this layer, Prometheus within this layer, Jira, Confluence, ELK within prod layer. But what happens here is when we are dealing with this kind of like softwares which are just for management, so we need to have a separate VLAN for this. And because it is not mandatory that DMZ servers will have directly connected with database, application servers will have directly connected with the database. No, that is not required. But Jenkins servers will have connectivity, will need connectivity with DMZ servers, with prod and with DB as well. Ansible server will need to have connectivity with DMZ, prod and DB. Prometheus will need to have connectivity for monitoring purpose with DMZ, prod and DB. Same thing like Jira. Jira will need to have a URL that should be accessible by every single person available in the organization's office. Let us say we do not want Jira should be accessible over internet. We need to have a kind of VPN service available using which we shall be able to perform our task tracking and all. Same thing goes with Confluence and ELK. So if this is the particular case, so we can create these particular services into management zone and then we can utilize the particular services. Are we clear with that, guys? Any questions so far? Guys, any question?
Is the Route 53 enough to resolve all the DNS things, or can we integrate with something like Cloudflare and all?
Come again? Your question is not clear to me. I'm sorry.
Is Route 53 can resolve all the DNS queries, and can we integrate with Cloudflare and all?
Well, that completely depends, like how you have designed your infrastructure. So if you want to host your domain onto Route 53, then you will have to define the particular URL of Cloudflare into Route 53, because whenever request will come to your domain, let us say you have a domain, let us say burger.com. So you will create an entry of burger.com into Route 53. Let us say it is www.burger.com. So you will create an entry of this URL into Route 53. And where will it point? So let us say you have ensured that right now, whenever a request will come for burger.com, you will want that request will be served from some Cloudflare. So Cloudflare URL, right? Now, what do you want? That whenever request is being served from Cloudflare, or let us make it in different way. So whenever request would come, so you would want that request should be going to your, what do I call? Cloudflare. So guys, those who are not aware of Cloudflare, this is a CDN platform just like Akamai. Furthermore, when request will come to Cloudflare, so for further processing, it will send request to your ELB, which is this one, right? Then after your internal microservices. This is how it will look like. Because if you want to use your caching mechanism, burger.com, and where are these entries going to be? First of all, you will make an entry within your Route 53, which is DNS service. For burger.com, you will point out to a URL of Cloudflare, which they will provide you against your domain name, against the particular service, which you are going to host there. Then Cloudflare will ask that if we do not have any cached data, then where to forward request? You will forward the load balancer DNS name into Cloudflare. Then it will forward request to Cloudflare rather than DNS forwarding the request directly to this particular internet facing application load balancer. Request will start coming from Cloudflare itself. Now, I hope that is clear, guys.
Yes.
Okay. Now, let us say if, let me ask you a particular, okay, are we clear with 3-tier architecture, guys? Or do we have any other question?
I have a question.
Yes, guys.
I have a question. So, just give me one moment. With respect to the management zone, would that still be within the same accounts in AWS, or are we basically, by calling it management zone, is it more or less a subnet construct, or we're creating those Jenkins Gate like in a different account entirely? I don't know, do you understand my question?
Yes, I got it. Okay, now let me tell you that how does that work. So guys, when we are talking about this kind of infrastructure, so what do we have? Let us say we have a single VPC, like this is our infrastructure. Let us not call that VPC. So what happens here is there are 4 categories, first of all. And the categories are, first of all, we have the first category as DMZ zone. Second zone is known as prod zone. What is known as your, let us call it DB. Let us say fourth is known as your management zone. Now, your DB can be part of this prod zone itself. Your DB can be part of prod zone itself. Or like if you want to keep DB and prod zone same, so what we can do here is we can define another zone which is known as TND, test and development. So this is how it looks like. Now, how do we define it? So first of all, guys, if we are talking about like this is part of single VPC. So there will be different route tables created, different RT. Different route tables will be there. For management zone, there will be different route tables. For TND, there will be different route table. And for prod and DB, there will be different route table. But if we want this particular system to work in such a manner that we do not want to create different route tables for different zones, we want to create different separate VPCs. So guys, keep this in mind. Either we can have separate VPCs, and then we can define those VPC as DMZ VPC, management VPC, prod, or maybe TND. But after that, what is required here? We will have to initiate VPC peering connection from this to this, from this to, let us say from this to this, from this to this. So this kind of connectivity will be required, guys. Like every single DMZ will be connecting with prod will be connecting with management will be connecting with DMZ and prod both, right? TND will be kept isolated because we really do not want to have connectivity between TND and production servers. So this is how we can maintain. So either we can declare that either these are on different what do we call route table, or we can create a separate VPC. If it is cloud, so we can either call it separate VPC, like let us say VPC1. And if you want to define another VPC kind of stuff here, you can define a VPC2, VPC3, and VPC4. So based on the requirement and based on suggestion, it can be kept as like different VPCs, right? Now, what are the advantages and what are the disadvantages? So guys, if you create different VPCs, so there will be a particular VPC peering connection created. Whenever we create VPC peering connection, all the data, whatever travels from one VPC to another VPC, maybe from one account to another account. So in that particular case, whatever data is being transferred, you will be charged for that. You will have to pay unwanted charges, because if these are part of same VPC, on private IP address, whatever amount of data is being traveled, there is no charge for that. Moreover, latency will be very less. Second thing, if you have enabled VPC peering connection, there will be public IP address utilized for it. In that particular case, all the data being transferred between like DMZ to like management, from management to DB, or from DB to DMZ, whatever data is being transferred, every single request will be counted and that will be chargeable. So ideal topology here should be that we should be relying on different route tables for DMZ, management, and prod zone instead of creating different VPCs. Are we clear with that, guys? Because if you are working with high volume of traffic, then this particular data goes into multiple terabytes. Every single day, multiple terabytes data can be transferred. Getting point? So that may convert maybe multiple $1,000 you will have to pay. Just to ensure, and just because you have created a wrong diagram here. Are we clear with that, guys?
Yes. So are you going to talk about route tables in this session?
Yes, I'll talk about.
Okay, all right.
And so, one more thing, I have seen somewhere that for AWS specific workloads, they are using AWS code commit and AWS pipelines as well. Can those be used instead of Jenkins and all?
Yes, there are different tools. So let us say if we talk about GitHub, so even GitHub is providing runners as of these days. So you can use that instead of Jenkins. So based on the environmental structure, you can use any tool for build and deployment. Maybe you can use GitLab runners, you can use Jenkins, you can use code pipeline, code build, code deploy. So any kind of tool can be used, but end of the day, what is mandatory, what is necessary to know that if there is a requirement how to enable and how to utilize the tool, what is the methodology being used, what is the sequence of it, what should be the flow of this application. So if you know that kind of thing, that it means you are good to go.
Yes, thank you.
So let us say if you have learned AWS code pipeline, so it will not be difficult for you to handle Azure environment. Reason being, coding you know, programming you know, concept is well known to you. Jenkins you have already worked with. So whatever is the environment, so environmental specific tools will not be a challenge for you if you know the core concept of it.
Yeah.
So if you talk about me as of today, so I can handle with AWS, GCP, Azure, Alibaba, DigitalOcean. I have worked on all these platforms. Because if you know the concept, there is nothing left. Okay, guys, I have one more interview question for you. And this is going to be really, really important for you to understand. Let us say I have like a data center in AWS. Let us say it is Mumbai. There are 3 availability zones. Now I need to host 3 kind of applications. Applications are going to be, let us say, web, app, and DB. There are 3 different kind of applications going to be. Now you need to design a VPC. I hope that you understand VPC. What is VPC? Virtual Private Cloud. So you need to design a VPC in such a way that all the particular web services, application, or database services should be running in HA mode. How will you design that? How many subnets will you create for that? Yes, guys, how will you create different subnets?
Can you repeat the question?
Question is, I want to design a VPC in such a way. Or let us add one more here. I want to ensure that my web services, okay, let us say that you are a new joinee in the organization ABC. Now you are given a particular task that you need to design a VPC in such a way. There are 4 different type of applications are going to be run. First of all, it is going to be web services, application services, DB, and management. So now the organization demands you to design a VPC in such a way. Let us say the region is Mumbai, where we have 3 different availability zones available. Let me show you what are the availability zones. It is AP South 1A, AP South 1B, AP South 1C. 3 different availability zones are there. Like if you see here, if I am able to show you that, just give me a moment. Yes, this is AP South 1B. So we have three different availability zones, like we have three different data centers available in Mumbai, 1A, 1B, and 1C. These three data centers should be utilized in proper manner, right? So how will you design that? How many subnets will you create? What kind of routing scheme you are going to put on that? So that kind of structure may be required by an interviewer to be designed by you during interview. That how many subnets will you create? And where will you align these web services, app services, DB, and management zone? If you are going to work as experienced person, maybe you are planning to show 3 to 4, maybe 4+ or maybe 5+ experience, that this is really going to be really great and good question for you. Who will try to explain this? Govind Raj.
Sir,
Your inputs.
um, I mean, as of now, I don't have any, sir.
Yeah, if I can try.
Yeah, please.
Yeah, so I think for each of the web, the app, and DB, we can actually create different subnets for each. And then within each subnet, we basically create 3 availability zones. And then for the web server, if we basically want those ones to be open to the internet, we can create, we can make those ones public in terms of the subnet. Basically we can make sure it has an internet gateway. Then the other subnets that do not require internet, like the app and the DB and the management, we can basically just create those ones as private subnets. In other words, it won't have an internet gateway.
So overall, how many subnets will be created?
4.
Will that be sufficient? First of all, let us design for web. There will be a particular subnet created in AP South 1A. Let us say we have a VPC size having size, let us say 10.0.0.0/20. What does that mean? Like 4,096 IP addresses will be made available within this particular CIDR. So the very first subnet which I'm going to have is going to be for web server, like 10.0.0.0/ okay, let us call it 1, like 1.0/24, and this will be for web. Another subnet I'll have here is, or let us call it subnet 1. This is subnet 1, right? This is going to be web subnet number 2, and this is going to be, let us say, 2.0. Third subnet I'll have here 3.0 and subnet 3. Right? Why did I create 3 different subnets, guys, here? Let us say if this availability zone goes down, so it means my web server will be running within AP South 1B and AP South 1C. AP South means Asia Pacific South. This is the region name for Mumbai, right? AP South 1. This is the particular region for Mumbai. Okay. So we have 3 different data centers in Mumbai, like AP South 1A, B, and C. So if this particular sub availability zone goes down, so though even I have like good enough amount of chances that my services will be running within 1A and 1C, right? That's why I have created 3 separate for web servers. Okay. Now let's come on to app. The same activity will be performed here for app. Why is that so? Reason being, when we are talking about app, so the particular subnet range will be 4.0, subnet number will become 4. Then after we will have another one. And rather than calling it web, let us call it app. The subnet is going to be for app. I need to modify that as 5. And one more here for 6. So guys, I'm taking some time over here in order to modify this, but obviously this is just to let you guys know that yes, this is how the architects are designed. Next is going to be for DB. Okay, now let us define it for DB. What is going to be number of this? 7.0, and subnet name is also going to be DB subnet 7. This is going to be 8. Now guys, keep this thing in mind. IP address will remain same, will remain different, but you can call it DB subnet 1, DB subnet 2, DB subnet 3. This is how also you can define. Naming convention will be only up to you, but based on this particular octet, I'm giving the names to this subnet as well. That will be up to you only. Either you can give the sequence number to every individual service, or you can give it based on the third octet of this particular service. Now, the very final thing which is left here, that is known as management servers. Okay, now once again, what will be the number of this? 10 guys. Management subnet 10. And finally, it is going to be 12. So now, guys, you tell me, do you find any kind of loophole here which can bring the infrastructure down? Yes, guys, do you feel that this can bring any service down? Okay. Now, when we have created all the subnets within same data, within same region, under all availability zones, now how these are different? So guys, let me do one thing. Let me try to keep web here, app here, and DB over here, and management here. And let me try to tell you like how these will be isolated. So first of all, on the top of subnet, there is a particular component which is known as route table created. Over here, we will have a public RT. Public RT means route table. There will be a component known as public route table. Why it is so public route table? Because along with public route table, there will be a particular gateway associated, which is known as internet gateway. Over here, when we are talking about app, so over here, there will be a particular other like private route table. There will be private route table associated and a gateway, which is known as, what is that, guys? Net gateway will be associated with this because no one from internet will be able to access these servers, but based on requirement, these servers will be able to access internet gateway. Based on the requirement, these servers will be able to access internet with the help of net gateway. But from internet, no one will be able to reach out here. Once again, we are going to have a private route table like placed on the top of DB servers and no gateway. No gateway will be there, but yes, these DB servers, because see, if you see all the IPs like 10.0.0.0/20, this is our CIDR value. This is known as CIDR value, classless interdomain routing. So web server will be able to reach out to management. Management will be able to reach out to DB. DB will be able to reach out to management, web, and deep and like app servers. Every single server created within all these 12 database, within all these 12 subnets, will be able to communicate without having any additional policy implemented. Second thing, if you want, let us say that DB server should not be communicating to management or management should not be communicating to web. So you can place one ACL on the top of these subnets. You can place NACL. You can place an ACL everywhere, wherever you want. In order to enhance the security level of it. Right, guys? So over here, no gateway will be there. And when you talk about management zone, so either you can have public or private. Public / private route table associated with management zone based on your requirement. Moreover, you can either have NAT or maybe you can have internet gateway associated with this. In most of cases, if you talk about general topology, then we do not have internet gateway. We usually have NAT gateway here because we want to run internet on these servers, but we do not want anyone from internet to be accessing these servers. So we can have here NAT gateway once again. So guys, do you feel that yes, we have isolated the network based on this? We have like created a separate segment on the top of this. How does this diagram look like? Are these isolated based on network category?
Yes.
Okay, is there any possibility that if any of the availability, let us say if this goes down, so will my application servers get impacted?
No.
Okay, let us say if management zone, like this one goes down, will my application get impacted?
No.
Let us say if this goes down, will my application, will my database get impacted?
No.
No? Yes, you guys are right. So when we are talking about this kind of appearance, what does that mean, guys? So we need to be very, very careful while designing this kind of network architecture diagram, because where what kind of services will be placed and how you are going to ensure like security is implemented. We have NACL. Public should be accessible over internet. We have public route table with internet gateway. Server should be able to access internet, but no one should be able to access these servers from internet directly. So we have private route table along with NAT gateway. NAT gateway allows you to access internet, but does not allow anyone from internet to access you. You means the particular instances which will be created inside these subnets. Private route table with no gateway. So we do not want database servers to be accessing internet, or we do not want anyone from internet to be accessing a database. Management zone. So public or private based, let us say we want to download some packages, we can associate internet gateway with this. We want to only run internet with on these servers, we can associate like NAT gateway or maybe internet gateway based on the demand. Are we clear with that, guys? Any questions so far?
I have a question. So if we don't have NAT gateway or IGW at the database level, how do we patch those servers, or how do we install certain dependencies on those servers?
Very good. So let me tell you, when we are talking about management zone. So I told you that management zone may or may not have public IP address, right? So let us say we have a particular component here, which is known as, let us call it YUM server. YUM, or in case of RHL 8 or 9, you can call that DNF server, right? So these service will be connected from internet, and this particular server will download the packages from internet. And now, because as I told you earlier as well, so DB server will have direct connectivity with this. So now database server will not be relying over internet, but database server will be relying on this particular DF like YUM or DNF server. This server will reach out to internet because it has NAT gateway or maybe internet gateway associated. Once all the packages are updated, then rather than our every individual instance is relying on such a server which is placed in public. So all of our servers will be relying on this. Oh, my bad. All of our server, let us say it is application server stack, that will be relying here. Same way, even this one subnet will also be relying here. Like every single subnet, whether it is in web, app, DB, or even management zone server itself, every single server will be relying for patching activity, for getting latest patch installed on these servers onto this particular instance only. Are we clear with that?
Yes.
So this server will reach out to internet to download the packages and all. Once this is up to date, then rest of servers will be relying on this particular component, which is known as DNF or YUM. And this is how patch will be applied. Are we clear with this, guys?
Yes, so we essentially would have to adjust some of the settings in the PB server so that whenever we do any YUM or apt-get, basically just route to another server instead of itself.
Yes, you are right. So let me define your APT as well here. So APT is for Ubuntu kind of flavor, DNF and YUM for Red Hat, CentOS, Fedora kind of. So your management servers will be responsible to download package from internet once packages are up to date. So like web, app, DB, and management servers will be relying on this particular server for package management. Are we clear with that, guys? Are we clear with that?
Sir, I have one doubt, sir.
Please go ahead.
Sir, what is the different public IP and private IP, sir? How to identify public IP and private IP, sir?
Okay.
Please give me one example, sir.
Okay, I can give you multiple examples. See, first of all, there are two types of categories of IP. IP address. If we talk about, there are two kind of IP addresses available, like IPv4 and IPv6. Now, when we talk about IPv4, especially because as of today, IPv4 and 6 both are being used equally. But yes, even IPv4 are more and more into use as of today as well. So if we talk about IPv4, this is a 32-bit logical address. Now, what is logical address? If this is logical, what is physical? So guys, MAC address is considered to be physical address, wherein IP address is considered to be logical address. Okay. Then it has 5 classes. The classification, the isolation of network is done based on the classes, right? What are the class names? Like class A, these 5 classes are there, where these particular IPv4 is isolated. Class A, B, C, D, and E. Now, keep this thing in mind. Every single class has 2 kind of IP address. Either it is public or private. What is the difference? Public IP addresses are accessible over internet. Like if you want to run internet on your system, on your server, on your laptop, desktop, mobile, or whatever device you have. So guys, in that particular case, public IP address is necessary to have. Private IP address will allow you to access kind of services onto intranet only. For example, that you all are part of a campus or a college or of any organization, and you do not want that particular content to be available over internet, but yes, you want every individual person should be able to access that within intranet zone. No internet, internal network you want to access it on. So you guys can access that service on the top of private IP address. Now, how these public and private IP addresses are decided. So there is an organization known as IANA. Internet Network Assigning Authority, IANA. That is our organization. So that has decided the range. So guys, keep this thing in mind. The range of A class goes from, if I talk about range, like range. So range of public, private IP, public, like class A goes from 1.x.x.x/8. This is beginning, and this goes up to 127.0, or let us say .x.x.x/8. This is the range. Now, what is value of x? So guys, x may stand somewhere. Okay, the x may stand somewhere. X equals to either 0 or 255. The x may value either 0 to within the range of 255. Either it could be 0, 1, 2, 3, 4, maybe 250, 253, 54, 55. It could be any. All the values can be any. Now, IANA has decided that yes, there will be private, like there will be public range and there will be private. So every single class has more and more public IP address. Reason being, because every single person wants to be over internet as of today. That's why it was earlier decided by IANA that we are going to have more and more public IP address instead of private. But yes, in order to make it accessible for individual organizations of small and large size, they have decided to keep one series of a specific IP address to be private for every individual class. So if we talk about class A, 10.x.x.x/8, this particular class is reserved as private IP address within class A. So if someone is going to ask you during interview, what is the particular series of class A? So guys, 1 to 126 is class A IP address range. And the particular mention which I have already did here is 127 dot, I'm sorry, 127, yes. Over here, 127.x.x.x/8. Guys, this particular is reserved for loopback testing. This is reserved for loopback range. What is loopback? In order to check the connectivity and functionality of LAN card itself. Let us say you purchase a new LAN card. So is it working properly or not? In order to check the functionality of that LAN card, loopback address are required. So wherever you go, you will find one IP address default configured 127.0.0.1. That is known as default loopback address. So this is private IP address range of class A, 10.x.x.x. I would not say 10.0.0.0. No, I would not say that. This is X. Let us say 10.255.255.254.0. Let us say 10.247.248.249.0/8. Right? So any number coming between this particular range can be replaced with this X. Clear, guys?
Yes, sir.
Okay. Now, if I talk about class B, so what is the range? Anyone? Okay. 128 to 191. Obviously, we are supposed to make it like x.x.x less 16, And over here 191.x.x.x/16. And the private IP address range is public, all remains public and private. Who will tell, guys? Yes, guys, who will tell? 172.16.x.x/16, and this range goes to 172.31.x.x/16. So guys, if any IP address is lying out of, let us say if it is 172.15, will it be public or private, guys?
Private, sir.
Let me ask a question. I'm sure we have a special session for networking. So is this you just charging based on network, or because he only asked about private and public IPs? So I don't know if you want to go depth, because I'm sure we have session for network.
Okay, so let me tell you that there is a particular separate stuff which is known as CCNA, Cisco Certified Network Administrator. So that course brings each and everything, like what is subnetting, what is IP addressing, how do we calculate the subnet mask, how do we go for like VLSN, CIDR, like everything. So if it is 15 in this particular case, guys, I'm just giving you a particular overview just to understand like what is private and what is public IP address. So yes, if it is 15 or it is 32 here, that will become public IP address. And as I told you, these are already fixed and identified by INA itself, who is authority in order to decide the public, like public or private IP address range. Now, what is next, guys? This is going to be, let me tell you what the range. What is range of this?
Sir, 192, 223, sir.
Okay, and what is private IP address range?
One 192.168.x.x by 24.
192.1.
168.x.x/20.
Yes. And what is range of D class? I have just pasted the same stuff within chat box for your reference. You guys can go through it. And guys, tomorrow onwards, we are going to continue with AWS first. First of all, we will discuss what major services of AWS, then Linux, then DevOps tools, right?
Yes, sir.
One question, sir.
Yes, please go ahead.
Can two apps can have same private IP in different network?
Yes. Let us wait. Let us say that we are two different customers. One account you are holding, another account I'm holding. Until and unless my services are supposed to communicate with your services, we can have same set of IP addresses. Let us say the same CADR I have and same CADR you can also have. But if there will be a need, like I need to get data from your services and you need to get data from my services from my account. If IP address range or CIDR range is same, there will be no possibility to communicate between your services and my services. We need to be on separate CIDR value in order to like connect with the help of, let us say, the particular services which we call it like VPC peering. That will not be practically possible. Are we clear, guys?
Yes, sir.
Yes.
Okay, so from tomorrow onwards, we are going to continue with AWS services, and that this is the like third and free demo session for everyone. Tomorrow onwards, I shall be sharing these sessions, and only registered candidates will be allowed. So please do yourself registered, and we are going to continue with very good stuff going forward.
So how do we register?
So okay, let me tell you, if you want to register from out of India, there is a PayPal ID lksingh009@gmail.com. This is my PayPal ID, lksingh009@gmail.com. This is PayPal ID, and those who are in India want to go for pay like Paytm, Phone Pay, Google Pay. That is my number 7838. Okay, let me define plus 91 7838793800. So like different payment, like payments of like Paytm, Phone Pay, Google Pay, like everything is accepted here. Fees is 9,000 rupees in INR.
I have one question for you. That's my last question. It's a generic question.
Yeah, please go ahead.
When you enroll in an organization, like when you you start, like they already interview you, pass your interview, then they accept you. When you start work, but like the first week, how it look like first 2 weeks? This is just a generic question anyway.
Okay, so you mean to say when like we join any organization, like how do we like spend our first week?
Yes, like first 2 weeks, like they're gonna give you any tax or you're gonna do anything
See,
that.
So
Yeah.
when you join any organization, so there is a formal process which is known as induction, or you can call it that introduction. So that organization walks you through with their default policies, like what you are supposed to do, what you are not supposed to do, how many members are going to be in your team. Let us say if you need to apply for attendance on daily basis, if you need to spend for other activities, they would walk you through the infrastructure, how many servers do they have, what are the kind of services they are running, what will be your role and responsibility. Gradually they will start provisioning access for you, right? Then after they will start giving a very small amount of task. They will put you under observation with such a person who has already been part of organization. You will just see the person will work. Later on, that you will start work, the person will assign a task to you. In that case, you will work and person will observe. Gradually, all the tasks which have been repeated multiple times with you, so you will start working individually, and then if any help required, you can reach out to that same person who was senior to you.
Okay. All right. Okay. Yeah,
So like
that's what I want to know.
Yeah, it is not something that if you are assigned a task, they will just give you like, okay, this is a rocket and you need to fly. So this is a like, but this is a really gradual process. So they welcome you with very like open heart. Like most of organization, I do not talk about any exceptions one. But yes, whenever you become a part of any team, so they really welcome you because they want you to give very, very heartwarming welcome. At
Okay,
least
that's fine.
at least I do for my team, and wherever I have been, so like I have been like welcomed the same way.
Okay, now I understand. I thought maybe they would just give you a task to do immediately. So when you don't understand the system and all. So
See,
that's what
buddy, listen, until unless you are not aware of the organization, how will you be able to perform?
makes sense.
Right?
That's my question. I was just eager to know. That's why I said let me ask.
Completely fine. I'm always there to answer these kind of questions. So okay, guys, thank